right, today we're going to talk about even more factoring. And we are going to start off with factoring by grouping. So factoring by grouping, all you have to do is think GCF. And also remember, this is only ever going to work on polynomials with 4 terms. So to factor by grouping, essentially we're going to group together sets of 2 terms. We're going to group together these first 2 terms and group together these last 2 terms. So in my first 2 terms, I say, okay, what's the GCF of those 2? Well, they both have a 2a in common. So I factor out a 2a, which leaves me with an x minus 3y. Then I look at my last 2 terms. Well, I can take out a 5. And since this is a minus at the front there, I'm going to take out a negative 5. And that leaves me with positive x minus 3y. Oh, look at that. I have x minus 3y on both of them. The only way factoring by grouping works is if that happens. So x minus 3y is the first factor of my final answer. The other one comes from these 2 GCFs. So it'll be 2a minus 5. And I don't care if you put the 2a minus 5 first or the x minus 3y first. That is factoring by grouping. So let's do some more. To factor by grouping, I split it into 2 pieces. So I'm going to take my first 2 terms and my last 2 terms. Looking at my first 2 terms, I look for the GCF. I can take a c out of both of those. If I take a c out of 7cd, I'm left with 7d. And if I take a c out of c squared, I'm left with a c. In my last 2 terms, 14d minus 2c, I can take a 2 out, so a positive 2, and that leaves me with 7d minus c. Hey, look at that. Those 2 sets of parentheses are the same, which means that is one of my factors. The other factor is those 2 GCFs put together, so c plus 2. And there's my factored answer. One piece that's important here is that you could rearrange your terms to make it work better. Most of the problems I'm giving you are going to be in an order that already is helpful. So we're going to take our first 2 terms and our last 2 terms. In our first 2 terms, my GCF is 3u, which leaves me with a w plus 4z. In my last 2 terms, I can take out a minus 2v, which leaves me with w plus 4z. Hey, look at that. My factors are the same, so w plus 4z is my first factor. My second factor is 3u minus 2v. All right, to factor this one, we do the same thing. Group together the first 2 terms, group together the last 2 terms. The GCF of my first 2 terms is 4n squared, which leaves me 3n plus 1. The GCF of my last 2 terms, well, there isn't one. So our GCF is going to be a plus 1, which leaves me with 3n plus 1. That's fine because I still have those 3n plus 1s. And my other factor has got to be 4n squared plus 1. You always have to take out that 1 because otherwise our factoring by grouping method will not work. All right, again, we're going to group together our first 2 terms and group together our last 2 terms. The GCF of the first 2 terms is 5x squared, which leaves me with x minus 2. The GCF of the last 2 terms is 3, which leaves me with x minus 2. Hey, look at that. My first term is x minus 2. What's left over is 5x squared plus 3. And one more factoring by grouping example for us. Group together the first 2 terms and the last 2 terms. The GCF of the first 2 terms is x squared, leaving me with 2x plus 5. GCF of the last 2 terms is going to be 3, leaving me with 2x plus 5. My first factor is 2x plus 5. My other factor is x squared plus 3. All right, then we're going to talk about a sum and difference of cubes. This only works on polynomials with 2 terms. And it only works if the first term is a perfect cube and the second term is a perfect cube. If I have a perfect cube plus a perfect cube, it will factor into a plus b times a squared minus a times b plus b squared. We'll talk about that in a moment. a cubed minus b cubed will factor into a minus b times a squared plus ab plus b squared. So my first one, y cubed minus 8. Well, my a in this case is y, because what thing cubed made y cubed? My b in this case is 2, because 2 cubed made 8. And notice the minus. So I factor into a minus b, so y minus 2, times a squared, which is y squared, plus a times b, well, y times 2 is 2y, plus b squared, 2 squared, which is 4. For our next one, what cubed makes 64z cubed? Well, that would be 4z. What cubed makes 27? Well, that would be 3. So I have my a and my b. It's a plus, so I follow the plus pattern. A plus b, so 4z plus 3, times a squared, well, 4z all squared makes 16z squared, minus a times b, which makes 12z. Always a plus sign, b squared makes 9. Now, if I tried to factor this piece, it's impossible. It's never going to factor. Don't even worry about it. All right, 27 minus 8x cubed. Well, what cubed makes 27? That is 3. What cubed makes 8x cubed? Well, that is 2x. So I take a minus b, so 3 minus 2x, times a squared, so 3 squared is 9, plus a times b makes 6x, plus b squared makes 4x squared. For a cubed plus 64, well, a is definitely a. Our b value, what cubed makes 64? It is 4. So I take a plus b, so a plus 4, times a squared minus a times b, which is 4a, plus 4 squared, which is 16. Now we're going to switch it up a little bit, because this first term is not a perfect cube. Neither is the second term. But we can take out a GCF. I can take a 2x out of everything. That leaves me with 125x cubed plus 64. Well, now 125x cubed is really 5x all cubed, and 64 is 4 cubed. So my 2x is along for the ride out front, and now I have a sum of cubes. So I do a plus b, so 5x plus 4, times a squared, which makes 25x squared, minus a times b, which makes 20x, plus b squared, which is 16. And for our last one here, x cubed minus 216x cubed, or sorry, 216y cubed. Well, our a value is just x. Our b value, what cubed makes 216? That's actually a 6y. So we're subtracting, so our a minus b, so x minus 6y, times a squared, so x squared, plus a times b, so 6xy, plus b squared, which makes 36y squared. And now we are going to throw all the stuff, all the different factoring we've done all together to fully factor each polynomial. Always, always, always start with a GCF. I look at these, I can take a 3x out of everything. That leaves me with 12x squared plus x minus 1. Now I need to factor 12x squared plus x minus 1. Well, the most likely way that I think to break apart 12x squared is 3x and 4x. The only way to break apart a 1 is a 1 and a 1. Check my inside and my outside to try to get a plus x in the middle. I got a 4x and a 3x. This will work if it's a positive 4x and a minus 3x. So this first one gets a plus, the second one gets a minus. For our next problem, we're going to start with the GCF. Well, I can take a y squared out of everything, which leaves me with 9x squared plus 60x plus 100. And that was my GCF. So now I'm going to attempt to break apart 9x squared. I could do 3 and 3 or 9 and 1. I'm going to try 3x and 3x. There's a lot of options for breaking apart 100. I'm going to try 10 and 10 first, because in the middle I get 30x. On the outside I get 30x. If those are both positive, that makes my 60x in the middle. I'm fully factored now. 343x cubed plus 1,000. Well, I don't see a GCF. I only have 2 terms, and the first term is definitely a perfect cube. So what cubed makes 343? That's 7. So my A is 7x. And what cubed makes 1,000? It's 10. So I have a sum of cubes. So I take A plus B, so 7x plus 10, times A squared, so 7x squared is 49x squared, minus A times B makes 70x, plus B squared, which is 100. For 2k minus 32k to the 5th power, I start off with my GCF. I can take a 2k out of each term. That leaves me 1 minus 16k to the 4th power. Well, now I look at this, I have 2 terms, but 16k to the 4th power is not a perfect cube. But it is a perfect square. So this is actually the difference of squares formula. My 1 can only break apart into 1 times 1. 16k to the 4th can be 4k squared and 4k squared. If 1's a plus and 1's a minus, that means I have no terms left in the middle. But wait, there's more. I can't factor a sum of perfect squares, so my 2k and my 1 plus 4k squared are stuck. But I can factor 1 minus 4k squared, because again, it's a difference of perfect squares. The only way to break apart 1 is 1 and 1. 4k squared can be 2k and 2k. To get the minus in the middle, we do 1's a plus and 1's a minus. Now we are fully factored. All right, for this next one, I look for a GCF first. No GCF that I can take out of everything. I have 4 terms, which tells me I have to factor by grouping. So I'll group together my first 2 terms, and I'll group together my last 2 terms. In my first 2 terms, my GCF looks to me like it's going to be 4x squared. That leaves me with 5x plus 12. In my last 2 terms, it looks like I could take a negative 1 out, making it positive 5x plus 12. Hey, look at that. My 5x plus 12 is my first factor. My other factor is 4x squared minus 1. But wait, there's more. 4x squared minus 1 is a difference of perfect squares. So 5x plus 12 is hanging out. Anytime I have a difference of squares, I undo the square on the 4x squared, making it 2x and 2x. I undo the square on the 1, making it 1 and 1. 1's a plus, 1's a minus. And one last problem for us here. Start with my GCF. My GCF to me looks like it's going to be 4c. That leaves me, 4x. No, what am I doing here? That x should be a c. Okay, so it was 4c. That leaves me 2c squared minus 9c minus 5. Well, now we have to try to factor that 2c squared minus 9c minus 5. My 4c's along for the ride. To break apart 2c squared, it has to be 2c and c. Multiply to 5, it's either 5 and 1 or 1 and 5. I think it's going to go like that, because 1 times c is c. 2c times 5 is 10c. To make that minus 9 in the middle, I need negative 10 and positive 1. So plus 1 minus 5, and we are fully factored.